Welcome back, ladies and gentlemen. In this video, we are going to be working on our success criteria, in which our goal is to prove mathematical statements about congruent polygons, specifically triangles today. And we are going to focus on triangles in a relationship is how can we go about physically proving that all of the corresponding parts are congruent? Because that's where we are right now, all right? At this moment in time, we have decided that we prove that figures are congruent by basically representing, right, that all of the corresponding angles, sides, are congruent to one another. So how can we prove this into actually some, yes, mathematical, two-column, paragraph, flowchart proofs? Let's go into a couple of properties real fast. First and foremost, reflexive, symmetric, and transitive. These should not be new to us by any means. But I want to point out that the properties of reflexive, symmetric, transitive that we have used for angles and segments like crazy also hold true when you're talking about triangles or figures in general, right? Let's go to our transitive property just real quick. Remember, we always kind of think of it as if A equals B and B equals C, then A equals C as well too, right? It makes sense because it's literally the exact same concept, whether we're using angles, segments, or our triangles. Okay, now, into our first proof. It says, use the information given to prove that triangle ACD is congruent to triangle CAB. Ooh, funny. Excited for the next couple of sections coming up here, folks. We are going to be diving into some of my favorite parts of geometry, utilizing proof in congruency statements. So, what do we know? Well, we have a lot of things given to us. Well, let's go ahead and label them first and foremost. We know, whoops, apologize for that. We know that AD, the segment, is congruent to CD, the segment. And we also know that DC, the segment, is congruent to BA. That's given to us. What else do we know? Well, we also know that AC is congruent to itself. What? How's that possible? That's not labeled. But remember, I'm going to be giving you two look-fors, two number one look-fors when we are talking about tricongruency. Get ready to write them down if you don't know them already. The two number one look-fors when we are proving that triangles are congruent is look for shared sides. Look for shared sides. Number one, look for shared sides. And number two will be to look for vertical angles. You'll see here why I think they're the number two and number one look fors in proving triangles congruent. Why is it so great to find shared sides? Because anytime two triangles share the same side, that side has to be congruent in both triangles. So it's the easiest side to utilize when it is shared. Well, what makes two sides that are the same congruent to each other? Well, what do we just see on the last screen? We saw that it is the mirror, it is the reflection, right? Your reflexive property. All right, so remember what our goal here. Our goal is to show these two triangles are congruent by proving that all of the parts are congruent. Let's recap so far. I have now shown that the reflexive piece is congruent to itself. 1, 2, 3. 1, 2, 3. All three sides taken care of. One angle, one angle. Two angle, two angle. I have one more angle. Let's think about this. I now have shown that all but one angle are congruent in pairs. What did we talk about in our last video that allowed us to say if two pairs are congruent, then the third one is as well? Well, ladies and gentlemen, that allows us to go ahead and to say that these two angles are congruent to one another. But then angle D is congruent to angle B by the what, by the what, by the what? Third angles theorem. Again, if two pairs of congruent angles are congruent, then the third angle is congruent. Now, I want to step back real quick and I want to talk about number 3, how it is written. Remember how I told you guys order matters? Order matters, order matters, order matters, because it has to be corresponding positions. So let's take a look. We have angle ACD. ACD has to match on up with CAB. How do I know they match up? Let's go ahead and just look here. One arc, two arc. From one arc to 2 arc to no arc, right? You kind of just match up which ones and which order you're going in. And then angle B and angle D. Well, Mr. McGuckin, why can we just call it angle B and why can we just call it angle D? Well, ladies and gentlemen, let's think about this. We don't have a second angle D. We don't have another angle B. So make your life easy. Just call them D and B. Here, you can't call it A because the question I have for you then is, which angle A? So what have we done so far? We have now gone ahead and shown that these angles are also congruent. As far as I can see, all of the sides that correspond are congruent, all of the angles are congruent, and so that shows us that those two triangles are congruent because all corresponding parts are congruent. Now, what you might be thinking is, oh my goodness, I have to show that every single angle, every single side, every triangle is congruent? No, not always. In our next section, we're going to be diving into 5 specific ways to prove that triangles are congruent without having to find every single pair being congruent. And I promise you, life gets a heck of a lot easier.